solving of the question number 6. Let's go on with the problem. Coming to the question which is given over here is air at 15 degrees centigrade and 1.05 bar occupies a volume of 0.02 meter cube. The air is heated at constant volume until the pressure is 4.26 bar and cooled at constant pressure back to original temperature. Calculate net heat flow to or from the air and net entropy change. Coming back to this, the second bit, the entropy change, we'll do it later because the entropy we are calculating actually at number 3. So I'll put it aside till the net heat flow of the air we'll try to calculate. Okay. So coming to this is a very simple question which has been asked for about 6 marks in January 2013. Okay, 3 marks is for net heat flow and 3 marks is for the entropy change. So this, let us understand that, and also let us try to draw the PV diagram first. Coming to this PV diagram, for the process 1 to 2, it is given as constant volume. And next is for the process 2 to 3, it is given as constant pressure. And next is process 3 to 1 as isothermal process. PV is equal to constant. So this is your actual PV diagram. So in this, what is we need to calculate is net heat flow. Is what we need to calculate. So what is given data? Let us write down. At state 1, it is given as temperature as 15 degrees centigrade, and next pressure is given as 1.05 bar, and next V1 is given as 0.02 meter cube. Okay, this is at state 1. Next, at state 2, the properties for this is volume is constant and P2 is given as 4.26 bar. This is P2. Okay, and at state 3, as pressure is constant and T3 is nothing but it is given something like original temperature. So T3 will be equal to T1 will be equal to 15 degrees centigrade. Okay. So these are the given data. So in this Q net is we need to calculate. How do you calculate Q net? Q net is equal to heat which is added minus heat rejected. Then you will get net heat. So this, coming to the process, where is the heat has been added and where is the heat been rejected. So in the process 1 to 2, Q is added, and in the process 2 to 3, Q is being rejected. Okay, so difference of this two, that gives you the actual net flow. Okay, so how do you calculate Q net? To calculate Q net, let us try to calculate the heat added. Q, which is added, is nothing but heat has been added at a constant volume process. So for the constant volume process, as you know, heat, how do you calculate? Q is equal to mCV delta T. So it is equal to m into Cv into T2 minus T1. Okay, so here Cv is not given, m is not given, only T1 is given, T2 is not given. So this m and T2 is we need to calculate. Cv and Cp remains constant, as this is the system is over here as air. For air Cv is 0.717 and for air for Cp is 1.005. So here m is, how do you calculate? As you know, PV is equal to MRT. So in this, M is equal to P1 V1 by T1. So R is not given, we are not going to consider all that. So for this, M is nothing but P1, what is a P1? 1.05 into V1. What is V1 over here? 0.02 by T1 is given as 15 plus 273 Kelvin. Okay, so what is M? From this I have got the M value as 0.0254 kg. This is the value which I have got M. And next is T2 I need to calculate. So how do I calculate T2? As from this relation, P is directly proportional to T, where P by T is equal to C, where P1 by T1 is equal to P2 by T2. So from this, what is needed to calculate? T2 is needed to calculate. So from this, T2 is equal to P2 by P1 into T1. So what is P2? P2 is 4.26 bar by 1.05 bar into T1, 15 plus 273. So which the T2 value which I got is 1152 Kelvin. 1152 Kelvin. This is the value which I got. Okay. So now T2 is known, M is known, directly substitute, then you get Q added. Q added is equal to M is 0.0254 into CV, which I told you 0.717 into T2. That is 1152 minus T1, 288. So that gives you the value. Okay, which I got Q added is, where is it value? Let me see, 15735 joules. The value which I got. Okay. The Q added is known. Next Q rejected. Q rejected is equal to, which is at the constant pressure process. So it is mCp delta T. M into Cp into T3 minus T2. Okay. So it is equal to, M is nothing but 0.0254. Okay. Into Cp is, as I told you, 1.005 into T3. T3 is nothing but it is equal to T1. T3 is nothing but it is equal to T1. That's 288 minus T2 which is 1152. So for this I got the value as 22055. 2255 joules. Okay. So now Q net is added minus rejected gives you Q net. What was added over here? Added is, this will be minus. Why? Because it is rejecting. 15735 minus of minus will be plus, so that gives you the value which I have got. Two 2055. Which I got the value as 6320 joules. So this is the heat that is Q net. Okay. For this carries 3 marks. Another is the entropy one that will calculate in the next unit when you come across the entropy one. Okay. I hope this solution is clear. This is a very simple problem which is asked. Let's move on to the other problem with another session. See you soon. Thank you.